This is Precalculus section 1.11 notes. Today we're going to be talking about modeling variation, and there are different types of variation. The first type that we're going to talk about is direct variation. This occurs when one quantity is a constant multiple of the other. As a graph, direct variation is always going to be a straight line, and it is always going to pass through the origin. So we can draw any straight line here, but it's always going to have that point 0, 0 on the line. Since it passes through the origin, that's kind of significant because that means that the y-intercept is always 0. The equation is written as y equals k times x. And we can rearrange that to solve for k, because often we need to do that. So then our k, which is our constant of variation, can be found by dividing y by x. So this is read as either y varies directly as x, or y is directly proportional to x, and that's enough. We don't need a third way. So you can either say y varies directly as x, or y is directly proportionate or proportional to x. So let's look at our first example. P varies directly as w. Okay, so that tells us, this line right here, P varies directly as w, tells us that we have an equation that looks like P equals some constant of variation k times w. If P is 15, then W is 7. Use the given information to find the constant of proportionality. Well, if this is our equation, then to find K, we would just do P divided by W. So for this particular problem, our K value is going to be 15 over 7, and that would be our constant of proportionality. And that's all they're asking us to find for this one. The second example says the stopping distance d of a car after brakes have been applied varies directly as the square of the speed s. Okay, so let's talk about what that means. Varies directly, distance d varies directly as the square of the speed s. So that means our equation is going to look like distance is equal to some constant k times our speed squared, the square of the speed, not the square root, the square, so we're squaring it. And again, if we wanted to solve that for k, then k would be equal to d divided by s squared. So it says a certain car traveling 50 miles per hour can stop in 240 feet. What is the maximum speed it can be traveling if it needs to stop in 160 feet? So this is kind of a three-step problem. Before we can do anything, our first job is we have to find our k value. And our k value is going to be equal to, and this is where we use the information from the problem, it can stop in 240 feet. So our distance divided by our speed squared. So this is going to be 240 over 50 squared. So that's 240 divided by 2,500, which when you grab your calculator gives you, 0.096. So that's our k value. So now we can use our k value and we can plug it into our equation. So our second step, which is really no work, it's just a matter of plugging things in, is to write our equation. So our equation for this problem is going to be d equals 0.096 times s squared. And now we can finally use this to answer the question. What is the maximum speed it can be traveling if it needs to stop in 160 feet? So finally, when d equals 160, we get 160 equals 0.096 times s squared. So first we're going to divide by 0.096 both sides. That's going to give us 1,666.7. and that's going to be equal to s squared. So now to undo the squared, we're going to square root both sides. And we find that s is equal to 40.8 miles per hour. Now, yes, when you square root, you get a plus and a minus, but since this is a problem about speed, the negative 40.8 miles per hour really doesn't make any sense. So we're not going to worry about the plus or the minus. We're just going to go with the positive on this one. The second type of variation that we're going to talk about is inverse variation. And in inverse variation, y decreases as x increases. So this equation looks different. It still has k in it, but instead of y equals k times x, inverse variation is y equals k divided by x. And to find our k value, if we solve for k, we are multiplying y times x. This is read as y varies inversely as x, or we could also say y is inversely proportional to x. And so what this looks like is something like that. So it's kind of a curve. As our y values, or as our x values get bigger, our y values start decreasing. So example number 3 is an inverse variation problem. It says Boyle's law states that when a sample of gas is compressed at a constant temperature, the pressure of the gas is inversely proportional to the volume of the gas. So first we're supposed to express this relationship with an equation. It says the pressure of the gas, so pressure equals, is inversely proportional, so K divided by the volume of the gas. All right, so there's our equation. To find our K, we're going to be multiplying P times V. Part B says, suppose the pressure of a sample of air that occupies 0.106 meters cubed at 25 degrees Celsius is 50 kPa. What is the constant of proportionality? Oh, sorry, yes, that's correct. But I jumped onto the wrong problem. So again, I'm going to start by finding our K value, or actually that's all we have to do is find our K value. So our K value is going to be equal to our pressure times our volume. So K is going to be equal to 50 kPa times 0.106 meters cubed. So our K value is 5.3. The last type of variation we're going to talk about is joint variation. Joint variation relates two or more quantities. So it's going to be written as y equals, we're going to have our K value, but then we might have times x and times w. Okay, so it just relates multiple quantities together. And it's read as y varies jointly as x and w, or y is jointly proportional to x and w. Our last example has to do with joint variation. T is jointly proportional to x and y and inversely proportional to r. Okay, we're going to stop right there and we're going to write our equation. T is, so T equals, it is jointly proportional, so K times x and y. And it's inversely proportional to r. So that means r has to go on the bottom. So now we have our equation, okay? To find K, K is going to be equal to T times r divided by xy. Use the given information to find the constant of proportionality. So we know how to find K. Now we just have to plug in the information. So K is going to be equal to, let's see here, 25 that's our t, times 2, that's our r, over 12, that's our x, times 3, that's our y. So that's going to be 50 over 36, which reduces to 25 over 18, or if you changed it into a decimal, that would be 1.38 repeating.